Yes, class, am I audible? Yahya Zaina.
Yes,
Who
ma'am.
is this Mohammed Farhan? All right, class. So yesterday we started with Kirchoff's law. So basically two laws we have. Kirchoff's first law is known as the junction law, and it means that total current at a junction will be zero. Means whatever is the amount of current entering the circuit will be equal to amount of current leaving the circuit. Right? So that is the Kirchoff's first law, which we've seen. Kirchoff's second law, it is the known as the loop law. It means that around any closed network, the algebraic sum of charges in changes in potential will be zero. Means the net potential is zero. So this is what we have discussed. Yes, Mohammed Farhan. Which class do you have to attend? I think you have to join the breakout room, room number 2.
Yes, ma'am.
Okay. So, the things that we need to solve the Kirchhoff's law, the first point that we need to know is V is equal to plus E when we have the charges moving from the positive and coming into the negative. And similarly, when coming from the negative and entering into the positive, like this would be our circuit, then we'll take V as minus E. So you should be very clear when to take plus E and when to take minus E. Now, see, yesterday I was mentioning that we have to take direction along the current and direction opposite to the direction of current. What was all this whenever we have to study? What was all this whenever we have this present? So, see, class, what we'll do, let me show you the circuit directly. This is a question extracted from your NCERT textbook. So, it's a very important question. Farhan, please join the room 2. Okay, all the students are there. Khadija has also joined. Rishit, fine. See, so I'm starting with the Kirchoff's law, and how to practice it is, firstly, we'll have a network. Network of all the circuits which are present. So see, suppose here you have to take out the loops. Like this is A, this is B, this is C, this is D. So you have so many circuits present over here. Now you have to extract the loop over here. Before we form the loops, see, let us write down the values of the current. Let's write down the values of the current. All right. So if we have current present with us, then how will we be able to write it? So what I'll do first, whenever you have such circuits, no, start distribution of current. Suppose from here I have started the movement of the current I1. Fine. This is plus, this is minus. Current I1 is going. Let's say I2 has gone into this wire. If I1 is coming, I2 has gone. So it means in this branch, I1, see, I1 was coming, but I2 has gone. So I1 minus I2 is left in this branch, right? So we have to basically distribute the current. I1 minus I2. All right, so I1. So I2 was coming here, I2 was coming here. Let's say some I3, let's say some I3 current, or no, it cannot go here. This is the battery, no? So I3 will be coming here. Look here, class. This is another battery. This is another cell. So it will discharge one more current. Let's say I3. So I3 will come, I2 will come, and they will form I2 plus I3. You have to redistribute the current according to you. This is not a necessity that you have to solve only in a particular order or particular manner. All right, Khadija, you're saying something? Khadija?
No, ma'am.
Okay. So whenever you have anything present, it's not necessary that you have to solve it in a particular order. See, I could have started I1 from here. I could have started I3 from here. So this is not a rule which you have to follow. It's just that suppose my answer, let me just distribute the current first, then I'll tell you this point. So I2 is coming, I3 is coming, both made I2 plus I3. So I2 plus I3 came till here, and it let I1 go off, because in this branch I1 is present. It means it has let I1 go off. So from I2 plus I3, I1 has gone, minus I1. Now see, if we add these two, this part and this part, because see, both are coming together. So I2 plus I3 minus I1 minus, this is plus I1 minus I2. Look, I1 got cancelled, I2 got cancelled, only I3 is left. And look here, we had started with I3 only. So it means all the distribution of current is done properly. It means the distribution of current is done properly. Just a second. Okay, so we have distributed the current properly. Now see, I1 was coming from the cell, I2 went here, then I1 minus I2 was left in this branch. Now from here I3 was coming, so I2 and I3 combined and made I2 plus I3. I1 left, so I2 plus I3 minus I1. Then I1 minus I2 and I2 plus I3 minus I1 came, and which made I3 back. So while checking, this clears the fact that yes, I have solved and put the current properly, because if I have not put it, then some of the current would have been left. Now listen, class. Distribution of current can be done in the manner which you want. It's not necessary that you have to solve it in a particular order. It means, suppose, let's say so many students are there, let's say Rishita. Rishita was solving, and instead of I3, she has written here I1. Right. So it means whatever I have got I3 as 5 amperes. So Rishita will get I1 as 5 amperes. It does not mean that you have to go by the variables I1, I2, I3 like this. No, you have to look at the branch which is holding the current. If this branch has 5 amperes, so name it anything, I3, I1 or I3 plus I1 minus I2, whatever is coming, the branches should have the same value. If in this branch, I am getting the value of current as 1 ampere. So if somebody has taken this as I4, so their I4 should be equal to 1 ampere. And my I2 plus I3 minus I1 should be equal to 1 ampere. Means do not go by the method of simply just putting all the values and matching the variables. No, it's not necessary over here. You do not have to put all the values like this. You just have to tally up the branches. So the first step is done, that we have redistributed the current everywhere. That is our first step which we have to follow. Right. So you also have to first redistribute the current. And while you are adding these branches, like this branch was added with this branch. So I got I3 back. So if I was wrong at some place, if I had done some mistake in the calculation part, then I would have not got this I3 properly, right? Now see the second step. First is distribution of current. Second step is that we write the loop. Suppose I'm talking about this loop, this triangle which we see. So it is loop A, B, C. But see, A to B to C is still here only. I want the complete loop. So I'll write A again. A, B, C, A. Look, A, B, C, A. So I'm talking about this loop. This is clear? I'm talking about this loop. Now, you can take the direction clockwise, anti-clockwise as per your wish. I am taking here, let's say I'm moving in this direction. This is clockwise, right? Yeah, this is clockwise. Let me move clockwise now. All right. Look here, class. If I am moving from here, A to B, what is there? I have to write the total voltage as 0. So use V is equal to IR. V is equal to IR. So potential, this is equal to current into the resistance. Current in this branch is I2 and the resistance is 4 ohms. So it is 4I2, right? But class, what we have studied about the sign convention, if we are moving along the current, we take the direction as negative. And look here, class, I was moving along the direction of current, the direction which I had taken clockwise, and the direction of current in this branch, it is same. So I'll put minus here, minus 4I2. So from A to B, I have moved successfully. Now let me move from B to C. What all things are coming in the way? Just a resistor is coming. So how do we write the voltage? Current into resistance. What is the current in this branch? Current is I2 plus I3, right? And what is the resistance? Resistance here is 2. But what about the sign? What about the signs? Positive or negative? See, I am moving along the direction of current. Current is going down, right?
Negative.
We are also moving. Yes, negative. Good, yeah. We will put it as negative. Come to C to A. This is the last branch left in this entire loop. So if I am going from C to A, two things I am able to see. One is the resistor. Second, I am able to see the cell. So for the resistor, we use the Ohm's law, V is equal to IR. What is the current in this branch? I1. What is the resistance? 1 ohm. So that is simply 1 into I1, which is minus I1. Why minus? Because we are also moving along the direction of current. Current is towards the left side. We are also moving towards the left side clockwise, right? Now last portion. Negative, positive. Negative and positive. So how do we go? The current is moving from the positive out and going into the negative. From the positive out and negative. Look, this is the case. So what we have studied, that we put plus E. So that is plus 10. So plus 10 is equal to 0. This is our first equation equation, and this is how you have to construct and write all the equations. Fine. Tell me first, class, is this clear? Then only I'll move forward.
Ma'am, could you explain
Yes,
how
ma'am.
you got plus 10 is equals to 0?
This let me explain this again. See, we have distributed the current in a random order. We have distributed. It's just that from a cell only generate new currents. I1 has been generated from here. I2 I had taken, so I had to write I3 over here. Now look, after distribution of current, pay attention here. I have chosen the direction we are following, we are going to follow. It is clockwise. This can be in anti-clockwise also. You can choose it as anti-clockwise. You can choose it as clockwise. I'll tell you by all the methods, you will get the same answer, class. It's just that this method is very lengthy. That's why we try to avoid it. Otherwise, this has lots of benefits and lots of advantages. So see, we have started moving from A to B, right? We are moving clockwise. Current is also moving clockwise. So we are moving along the direction of current. Sign is negative. Current into resistance. I2 into 4 minus 4I2. Similarly, when we are coming down, this is I2 plus I3 into 2. Voltage is equal to current into resistance, and sign is minus because we are moving along the direction of current. Similarly, in this branch, when we have come here, this is resistance into current, gives us the potential. And since we are moving along the direction of current, we have minus sign. Look, from here, current is coming out of the positive one. Whenever the current comes out of the positive side, positive terminal of the cell, we always write plus whatever is the voltage. See, ultimately, we are writing total voltage as 0. What are these? These are ultimately the voltages, no? 4I2, 2 into I2 plus I3, 1 into I1, all these are voltages only. So this is the voltage here. You don't need to calculate using Ohm's law. You already have the voltage as 10 volt. So instead of calculating it, we already have the value directly. So that's why we have written it as plus 10. So see, once we have distributed the current, that times Kirchoff's junction law was done. Now we have equated all the potential to 0. Kirchoff's voltage law is also followed. Tell me, class, now is it clear or now you have any doubt?
Clear, ma'am.
Other students also, Zaina, Khadija, Rishita, clear?
Yes, ma'am.
Yes, ma'am.
Okay. So we can move on to this next loop. Let's move to this loop. Let's take this time the direction opposite so that you have an idea that you can take any direction. So which loop is this? A, C, D, A, right? A, C, D, A. Class, always write the first letter again. Otherwise, your loop will be incomplete. It won't be a loop. It would be a straight open circuit. Right? So we are going from here. Let's go from here. So this, we are going anti-clockwise, right? And the current here in this branch, at least in this branch, is going anti-clockwise. So see, we are moving along the direction of current. Current is moving towards the left. We are also going towards the left, right? This is our direction. This is our direction, anti-clockwise. So current, it will be minus I1. Come here, same thing. This is the same. Current is coming from the positive going into the negative. So it will be plus 10. These two were similar, exact, because here also we were moving like this. Here also we are moving like this. So same thing like this. Now the differences will come, especially in this branch. Now see, we are going like this. Now this branch. So here also we are moving along the direction of current, right? So it is minus 4 I1 minus I2. This is current into resistance, right? Current into resistance. Now, we are going up. We are going up, but the current is coming down. So we are going up, but the current is coming down. It is the opposite direction. See, till here, everything was matching. But as soon as we are coming to this branch, it is in opposite direction. So it means this time it will be plus resistance multiplied to the current I2 plus I3 minus I1 is equal to 0. This is the second equation. Clear, class? This is the second equation. Last loop is also left. Let me discuss that too. Let's take clockwise again. Let's take clockwise again. Whatever doubts you have, get it clarified in this final loop. So which loop is this? B, C, D, B. Yeah. This is B, C, D, B. So see, this is, so we are moving clockwise, and the current here in this branch is anti-clockwise. So this part will be positive, 2 into I2 plus I3, and this will also be 2 into I2 plus I3 minus I1, right? So it will be plus 2 I2 plus I3 minus I1 plus 2 into I2 plus I3. Lastly, look here, class, we are moving like this, right? This way we were moving. So only this wire is left, which has the cell. So current is coming from the positive and going, so it will be simply plus 5. So this will be plus 5 is equal to 0. So this is the third equation, right? Write it down. Any doubts, whichever branch, please let me. Then you can solve these three equations and get the values of I1, I2, I3. That's why we say this is a very lengthy method, and usually we try to avoid it. In very simple circuits, only try to follow very lengthy. You can see it's lengthy. Write it. Okay, class. So this is easier in comparison to the first question. First question had lots of loops. Now this has only two main triangles which are constructing and forming a major bigger rectangle. Now look, we'll be distributing the current. So firstly, this is our 5 volts. So let's make current I1 coming from here. So I2 goes in this branch, right? So this one has I1 minus I2 left. This has I1 minus I2 left. So same wire. So this will also be having I1 minus I2 left. Now I1 minus I2 and I2. When they are added, this is I2. When they are added, this will form I1. And look, in the same wire, we need I1 only. So easier, you just need two equations. So P, Q, R, S. So let's move here clockwise. Yeah, let's move. So when you are moving clockwise, see here, let's move from here to here. This is opposite to the direction of current. Which loop is this? P, Q, R, P. So if we are moving from here, it is opposite to the direction of current. So it will be minus I1 into 200. Then see, this is opposite direction, right? No, this will also be plus. Yes, we are moving here opposite direction. So it will be plus. Here also we are moving in opposite direction. So this will also be plus I2 into 20. Here we are coming. Here there is no resistor. We just have a single battery. Now what is the rule for battery? In the battery, we just check whether the current is coming out or coming in. So current is coming out from the positive. So it will be plus 5 is equal to 0. This is our first equation. Look at the second loop. Second loop is, let's move here, same direction. Let's take the same value. Let's move clockwise only. So what is this loop? This is PRSP, right? This is PRSP. So here we are moving along the direction of current. So this time it will be minus 20 I2. Then coming, this is in opposite direction. So plus 60 into I1 minus I2. This is also in opposite direction. So plus 2 into I1 minus I2. And see, this is negative, this is positive. So current is coming from the negative and going into positive. It is coming from negative. So it will be minus 4 is equal to 0. Second equation. We need to solve this and get the value. Write it down, class. Any doubts, please let me know. First, tell me, is it clear? This question is clear? I think you will find it easier than
Yes,
the...
ma'am.
Okay, write it. Done, class? Just text me done once completed. Okay, see class, Beach-Stone bridge we had discussed when we were discussing capacitor. So I had told you the balancing condition, right? But we didn't do the derivation of the balancing condition. So derivation of balancing of Beach-Stone bridge is done through Kirchoff's law. See, we'll distribute the current. Suppose this is the main circuit. Let's say I1, I current is coming. Let's say why make I1? Let's make the bigger I is coming. I1 goes into this branch, right? And I see, so I minus I1, right? I minus I1 will come in this branch. See, this branch where galvanometer is present, I am saying the current is IG. Okay, in this branch, current is IG. Now from I1, IG has gone. So this branch has I1 minus IG. This branch has I1 minus IG. Look, what will this branch have? I minus I1 plus IG, right? This term plus this will give you this. Now, when we add all of these, I1 will be cancelled, IG will be cancelled. So we'll be left with I. It means I have distributed the current properly. Now, see, A, B, D, A. Look at this. Let's move like this. So A, B, D, A. When we are going from here, let's move. So this is minus I1 R1, right? We are moving along the direction of current. So minus I1 R1. Come to this, we are moving along the direction of current. Here the resistance of the galvanometer is G. What is a galvanometer? That we'll do in magnetics. So it's basically a device to detect current. So resistance is G, current is IG. So minus IG into G. This is opposite to the direction of current. This is plus R3 into I minus I3. Right? This is entire term. This is equal to 0. Now, one thing class, I have told you when the bridge is balanced, then there is no current flowing through the circuit. So we have IG as 0. Okay, so this term IG will be 0. So what will be left? We'll have minus I1 R1 plus R3 I minus I1 equal to 0. Right? We'll be having this. Now come to the second loop. Come to this loop. B, C, D, B. So same, let's go like this only. So this is loop is B, C, D, B loop. Now see here, this is along the direction of current. So this will be minus. Then this is opposite to the direction of current. It will be plus. And this is also opposite. So it will be plus. So that is minus R2, I1 minus IG plus R4, I minus I1 plus IG. And last one was IG plus IG into G is equal to 0. Now this will be 0. IG here will be 0. IG here will be 0. Why? Reason again the same thing. Bridge is balanced. We write it as 0. So what will be left from here? Minus R1, R2 plus R4, I minus I1 is equal to 0. Now class C, let's have a look on both of these equations. This equation 1 and this equation 2nd. Let's divide them, right? Let's divide these two. So opposite side it is I1, R1 and it was R3 or yeah, R3, I minus I1. It is R3, I minus I1. And this is because this will go here, no, on the opposite side. So it will be I1, R2. This will be R4, I minus I1. I1, I1 got cancelled. These brackets got cancelled. So we are ultimately left with R1 by R2 is equal to R3 by R4. So this derivation can come that you need to know. Write it quickly, class.